Here we have two neighbors. They have rectangular lots. They're side by side and they share a fence. One guy's got an area of 36 meters squared. This guy's got an area of 45 meters squared. And they share a fence, or they share a side length. Well, that means that they must have a common factor. Common factor is a shared side length in our area model. So what is the longest fence that they can share? Or in other words, what is the greatest common factor? So this is a greatest common factor problem versus this one here is a lowest common multiple problem. So we're looking for the longest, the biggest small number. Here we're looking for the biggest, the lowest, smallest, big number. So that we're looking for the biggest small number here, where we break it up into pieces. Other one is the opposite. So what is the common side length that can be shared along this fence? We're looking for the biggest factor that these share. The biggest divisor is going to be 9. So this side length is going to be 9. That means he's got 5 meters here, and this is going to be 4 meters here. Now it's not drawn proportionally, but gives us the right area. So the greatest common factor is equal to 9. Okay, the fence length is 9 meters. That's the largest fence that they can share to have these same areas. Okay, so when we come up with numbers, we can find the greatest common factor. And for me, the best strategy, I think, is to use the prime numbers. So I use 2 times 2 times 2. Here I have 2 times 3 times 3. Here I end up with 2 times 2 times 2 times 3. Okay, so the greatest common factor is whatever's in common. Okay, in this case here, common 3's, common 2's. Okay, so the greatest common factor is equal to 6. That's the biggest divisor of all three. That one we can probably see by just looking at those numbers, because we're familiar with those numbers. The lowest common multiple, we just take one of each. So the lowest common multiple works out to be 8, 24, 72. So if we skip count, they all will skip count to 72, and that's the first time they meet, and then they meet again at 144, and keep on with multiples of 72. They will all end up meeting again. So again, I'm going to do the same strategy here. I've got 24. That's equal to 2 times 2 times 2 times 3. 36 is going to be 2 times 2 times 3 times 3. And 72 is equal to 2 times 2 times 2 times 3 times 3. Okay, so it's going to be 6 times 9. Okay, so there's our, it's going to be 8 times 9. Yeah. So there's our prime factorization. So again, the greatest common factors is we take as many of the ones that are common to all three. And we try to take as many as we can. Okay? We can't take these 3's here or these 2's because they're not common to all three numbers. So the greatest common factor is equal to 12. Okay, that's the biggest number that divides all of them. And if we skip count, okay, the first time that we meet, all three meet, is going to be at 72. So the lowest common multiple is equal to 2 times 2 times 2 times 3 times 3. That's 8 times 9, which is 72. So that's our lowest common multiple. So if we skip count, we can skip count all the way to 72.